One of the most respected and advanced minds in physics today, Michio Kaku, has recently weighed in on a groundbreaking discovery that's causing quite a stir in the scientific world. Known for his significant contributions to both classical and quantum physics, Kaku has publicly acknowledged the findings of the James Webb Space Telescope, which has detected 6 massive galaxies that current scientific models said shouldn't exist. These revelations could mark a turning point in how we understand the origins and structure of the universe, and they're certainly worth paying attention to as further research unfolds. Michio Kaku, a physicist of both American and Japanese heritage, has earned recognition for his openness to revolutionary ideas. While many in the scientific community remain cautious or even dismissive of disruptive findings, Kaku has embraced the possibilities offered by this new data. Rather than dismissing what the James Webb Space Telescope has uncovered, he's praised it, suggesting that these discoveries are not just important, they are profound. His enthusiasm is palpable, highlighting the deep interest he has in these early universe galaxies, which might change everything we thought we knew about cosmology. Kaku has long shown a willingness to consider bold new theories. He understands the limitations of established laws, such as Newton's principles and Einstein's theory of relativity, in fully explaining the complexities of our universe. The recent findings from the James Webb Space Telescope offer evidence that could enrich our scientific understanding in ways that traditional models haven't predicted. While many of his colleagues hesitate to reconsider the status quo, Kaku sees these developments as natural provocations for deeper exploration. For some, this news has sparked unease, especially for those heavily invested in Big Bang theory and traditional interpretations of quantum mechanics. But Kaku, rather than being troubled, finds the uproar amusing. The telescope's observations reveal 6 enormous galaxies formed remarkably early in the universe's history, between just 200 and 700 million years after the Big Bang. What's astonishing is that each of these galaxies appears to contain more stars than the Milky Way, challenging everything scientists thought they knew about how long it takes such massive structures to form. These galaxies have been nicknamed universe breakers by the astronomy team, because if the findings hold up, they could completely disrupt our current cosmological framework. According to the Big Bang theory, the early universe was extremely hot and chaotic, and it took hundreds of thousands of years for the first atoms to form. After that, millions more years passed before light-producing structures began to appear. Galaxies, particularly massive and organized ones, were thought to come even later. But these newly observed galaxies are not only large, they're actively producing stars at astonishing rates, possibly hundreds per year, unlike our own galaxy, which forms stars at a much slower pace. The timeline just doesn't match what we expected. It raises serious questions. Are our models of cosmic history flawed? Is the universe older than previously believed? Or did complex structures form far earlier than we've been assuming? These are difficult questions for conservative branches of science to face, and some physicists are already challenging the results, suggesting that errors in dating might be at fault. Kaku is aware of this resistance. He points out that throughout scientific history, many outdated theories held on far too long simply because of the reputations of the scientists who proposed them. In the end, it's the experimentalists, the ones who gather the data, who keep theoretical science in check. He emphasizes that despite decades of research, we still know very little about how the universe actually began. The Big Bang theory itself dates back to 1927 and was founded on observations that the universe is expanding. This led to the idea that everything originated from a single point. Back then, it was nearly impossible for most people, including scientists, to imagine a universe that had a definite beginning, or, potentially, an end. Many held on to the belief in an eternal, infinite cosmos. Even now, grasping the full implications of cosmic origin remains a major challenge. Yet these new findings directly contradict much of what scientists have assumed for generations, which makes re-evaluating those assumptions more crucial than ever. Science, by its nature, must remain flexible. Throughout history, what we once saw as absolute truths were often overturned by new observations. When Einstein was a child, it was still widely believed that stars and planets were fixed in place. Today we know the cosmos is in constant motion. Planets, Orbit stars. Stars travel within galaxies, and galaxies themselves speed through space in unpredictable ways. Understanding this dynamism was a huge leap forward, and the same openness is now needed as we interpret the new findings from space. It's a reminder that scientific theories are not eternal truths, but rather evolving models that must be rigorously tested and refined. The idea of a Big Bang grew from the observation that galaxies are moving away from each other at speeds proportional to their distance, what became known as Hubble's law. This supported the view of an expanding universe. Later, cosmic background radiation and the redshift of light from distant galaxies seemed to confirm it. But just as people once believed the Earth was flat, or that the sun revolved around us, those views changed as technology improved and evidence became clearer. Today we may be facing another turning point. Scientists expected the James Webb Space Telescope to confirm established theories, but instead, it uncovered 6 massive galaxies that don't fit those expectations. It's a powerful reminder that science is never static. It evolves with each new observation, and researchers must be ready to rethink even their most cherished ideas. A key tool in this research is redshift, also known as the Doppler effect, which helps scientists measure distances in space. This phenomenon occurs when light shifts toward blue as a source approaches, and toward red as it moves away. Just as a car engine sounds different as it passes by. Astronomers use redshift to calculate how fast objects are moving and how far away they are. But small errors in this process can lead to major inaccuracies. That's why the techniques used are now being scrutinized carefully. The question remains, are these findings a result of measurement errors, or are some scientists simply unwilling to accept the implications of the data? It's a debate that requires careful, thorough analysis. Only by revisiting the data and refining our methods can we determine whether these universe-breaker galaxies truly represent a major shift in our understanding of the cosmos, or whether they're just the beginning of even more surprising discoveries to come.